Welcome again, friends. Let us take step 3 of obtaining optimal solution of a transportation problem. In previous 2 lectures we have already discussed. First we discussed how to check the optimality of initial solution obtained by northwest corner method or least cost method or WAM. In second step we modified the distribution or allocation which we had already made in initial solution. Now this is the third step. We are going to check the optimality of this revised solution after redistributing the quantity or after modifying the redistribution. We already know that how to check the optimality. First we have to take 2 dual variables u, I and vj. We have to take any one value of u or v arbitrarily as 0. As I had suggested, it is advisable to take 0 where we have highest number of occupied cells either in a column or in a row. But here the case is not that much simple. In no row there are 3 or in no column there are 3 occupied cells. Now the situation has changed. 1, 2, 1, 2, 2, 2, 2. So in most of the columns or row there are 2 occupied cells. So let us take 0 at the place where in the first round we had already taken. We take V4 as 0 arbitrarily. On the basis of this we can calculate U1 and U3 with the help of these 2 occupied cells, because we need to calculate values of Ui and Vj through occupied cells only. Cij minus Vj, 10 minus 0, that will be U1, 20 minus 0, that will be U3. Now on the basis of these 2 values of U, we can find 2 values of V. With the help of 10 and cell 1, 1, we can find V1. C minus U, 19 minus 10, V1 comes to 9. Similarly, with the help of cell 3, 2 and U3, we can find out the value of V2. C8 minus U, V20, so V2 comes to minus 12. Now with the help of V2 and occupied cell 2, 2, we can find the value of U2. C minus V, 30 minus minus 12. So 42 is the value of V2. Now with the help of U2 and occupied cell 2, 3, we can find the value of V3. U, C minus U, that is V. C40 minus U42, so V3 comes to minus 2. So in this way, we have all values of dummy variables U, I and Vj. With the help of all these Uij values, Ui, Vj values and Cij values, now we can calculate opportunity cost for all empty cells. And the calculation is Dij equals to Cij minus Ui plus Vj. Let us calculate. The first empty cell is S1D2 or cell 1, 2. Let us calculate D12. The relevant C is 30. Minus sign according to formula. Relevant U is 10. Plus sign according to formula. Relevant V is minus 12. So it is 30 minus minus 2. It is 32. More precisely, the opportunity cost for cell 1, 2 is positive. Now cell 1, 3. Let us calculate D13. The relevant C is 50. Minus sign according to formula. Relevant U is 10. Plus sign according to formula. Relevant V is minus 2. 50 minus into brackets 10 minus 2. 50 minus 8. So it comes to 42. But important thing is D13 or opportunity cost of cell 13 is positive. Now D21. for cell 21 D21. Relevant C is 70 minus sign according to formula. Relevant U is 42 plus sign according to formula. Relevant V is 9. So it is 70 minus 51. It comes to 19. The important thing is it is positive. D12 or opportunity cost for cell, I'm very sorry, it is not 1 2, it is 2 1. Cell 2 1, it is positive. Now row 2, last cell 2 4. D24, the relevant C is 60 minus sign according to formula. Relevant U is 42 plus sign according to formula, and V, it is 0. 60 minus 42, it is 18, or precisely it is positive 18. That means the opportunity cost of cell 2-4 is positive 18. Remember, in the initial solution we had made allocation of 2 units to this cell. The opportunity cost is positive 18. That shows if we make allocation of 1 unit, the total cost will increase by 18, not from this one, because it is the total cost when we had allocated 2 cells to 2 units to this cell. But whatever cost of this solution is going to come, if we again modify the allocation and make allocation of 2 units here, the cost will increase by rupees 36. But we have say redistribution, make redistribution, and we have removed allocation of 2 cells from here, and in the modified solution or revised solution now we have a new allocation in this cell where the D was minus 18 in the previous step. Now calculation of D for the third row, S3, in which the first cell is empty, cell 3 1. So let us calculate D31. The relevant C is 40 minus sign according to formula. Relevant U is 20 plus sign according to formula. Relevant V is 9. 40 minus 29, again it comes to 11 or positive 11. And the last 3 3. D33, the relevant cost is 70 minus sign according to formula. Relevant U is 20 plus sign according to formula. Relevant V is minus 2. 70 minus 18. So it comes to 52, or more precisely it comes to positive 52. So what has happened? All the 6 Dij values or opportunity costs for all the empty or unoccupied cells are positive. If all the Dij values are positive, we can conclude that this one is the optimal solution. So we conclude that the revised solution is optimal solution because all Dij values are positive. Since all Dij values are positive, we conclude that the revised solution is optimal. So let us calculate the cost. It will be 5 units into rupees 95 rupees for this cell, 2 units into 10 rupees 20 for this cell, 2 into 30 rupees 60 for this cell, 7 into 40 280 rupees for this cell, 6 units into 8 rupees 48 for this cell, and 12 units into 20 rupees 240 for this cell. It comes to 743. Now what was the cost according to Initial solution, it was 779. 779 minus 743. This calculation is not necessary to show as a part of your answer. This is going, I am calculating this type of difference to say, explain some other thing. It is rupees 36. What is this 36? Remember, in the first step, when we had calculated Dij value first time, the Dij value for this cell was minus 18. The interpretation was, if we make allocation of 1 unit to this cell, the cost can be decreased by 18. And in the second step of redistribution, we allocate 2 units to this cell with the help of closed loop. And now what has happened? Minus 18 into 2 minus 36. 779 minus 36 equals to 743. The cost has decreased by 36. Remember, minus 18 into 2 is 36. So this is the optimal solution. Thank you.